Hello everyone, it's July the 10th. Alright, let's get down to it. All nodes distance k in binary tree. Given the root of a binary tree, the value of a target node, and an integer k, return an array of the values of all nodes that have distance k from the target node. So a target node is, okay, all the values are unique. That's good. We have 500 nodes. And target is 5, and the distance k is equal to 2. I mean, it's a binary tree, right? It doesn't really matter if we take this as a root. Well, we do have to. Oh, because if you set this as root, it's actually very simple. You just go 2 levels down and you're done. I mean, anyway, so you get to this, okay? You get to the nodes that you want, and from there, you can go k equals whatever, try to find it. Once you're done, then you need to find its parent, right? Like backwards traversing. That's interesting. Can you do backwards traversing? Or we go through the entire tree. Doesn't matter. And then we turn this tree into a graph. What do you think? You turn this tree into a graph. Yeah, I think it's definitely possible. We turn this tree into a graph. When this connects to this, I just get both sides. Get both sides. So then I can start from 1 and just, BFS. Right? And then when BFS, I can go here. You know what? I'm going to try that one. Yeah, I'm going to turn that into a graph instead of just a tree. And then the answer will be very simple to do. All right, so we're going to do a graph. Okay, default dict, and then be a list. And def DFS. Well, I like to do DFS. Okay, no, this tree node actually is going to be optional. And don't return anything. Okay, we say if node. Then what do? We have node.left, node.right, right? Then we just say if node dot, and this can just be a number of nodes. Yeah, okay, that's fine. Then we can say if node.left, graph node.val dot append node.left dot val, graph node.left dot val dot append node dot val, if node and DFS node.left. And we do the same thing with right. Okay, then when we're done, we can say DFS root. Then we have built the graph. So the graph is built. I will just call Q equal to target. All right, and while Q, and we have a result. Hold a second. We don't need a result. While Q temp. Okay. Then we say if, so k initially is 2. Every time we go 1, k minus equal 1, right? We do 1, k minus equal 1. So I shall say and k, right? And then we say for node in queue, right? And then for child in graph node, we also need seen visited. That's going to be a set with target in it. Okay, for child in this, if child not in visited at child, and temp.append child. When we're done, q equals to temp, k minus equal 1. Once we're done, return q. What do you think? Well, we start with just this, right? And k equal to 2. Now we go, so the next level is going to be 6 to 3, okay? Q is 6 to 3, k equal to 1. Okay, back up. 6 doesn't have anything. So 2, so now we have 7, 4, 1, right? 7, 4, 1. K minus equal to be 0, come out. Looks to be solid, so we're going to have to test this first.
Oh wow, someone got drafted to MLB.
Whom?
I don't know.
FAU?
Yeah.
Oh wow.
Didn't see the email.
I guess I just deleted. Wow, draft to MLB?
Yeah.
Ooh.
11th overall.
Ooh.
Is that good?
Oh, very good. 11th overall. That's very, very good.
Wow.
Wow, I didn't know they have a talent.
Well, at least one person.
One person is good. You know, they can now write this in the school recruiting, right? They're able to recruit better talents. They say, as our track record, we just got a MLB, just got drafted. That's great. Tree node is not defined. Of course it's not defined. Oh, what the hell are you doing, man? This is tree. You're not supposed to test it. Because you cannot test it. Sorry, I just forgot about this. Alright, let's hope it's right. That is very bad. Why am I getting empty? Okay, I have no clue why. I did a DFS, so... Alright, that's fine, that's fine. Let's take a look. Let's take a look. Something is not right. Okay, first things first. Let's take a look at the graph. See how graph does. Graphs are fine. 3 to 5, 1. 5 to 3, 6, 2. 6 to 5. 2 to 5, 7, 4. 7 to 2, 4 to 2. 1 to 0, 3, 8. These are all correct. These are all correct. Alright, so the problem is with BFS. What's wrong with BFS? Target, that's fine. 5, right? We have 5. Set is, that's fine. And for node in queue, so it's target coming out. For child in graph 5, so it should be 3, 6, 2. It's not in visited, we added this dot append. The k star is 2, right? Dot append. So q shall equal to, let's take a look at the q at every single time. See how it goes. Wait, that is weird. Nobody's appended. Huh? What is this shenanigan? Yeah, leave it on the floor. Destroyer. Jimbo the Destroyer. Okay, so this is not right, but why? What else can you try? Let's try this. Child. Oh, because child. Yeah, it's fine. Child. Node. Standard output. I don't understand. This one didn't come in. Wait, hold a second. Wait, what? This is bonkers, man. Oh, shoot. Target is a tree node. Dirt. Sorry, I was very wrong. Target is a tree node. I thought target is the value. He stuck his head inside.
He wants a drink?
I don't know. Oh, but this one's correct. Oh, it's submitted. I don't know, the milk. You got attracted to the milk.
Oh.
Oh my goodness. Oh my goodness. Well, next time he does it, you should take a picture. Alright, so we got this. Oh, so this has to be vowel. This has to be vowel. Well, it's not fast, but it's alright. A63. Turn the tree into a graph and then BFS. Well, I'll take ON to turn this into a graph, and we take ON to do BFS, so it's just like that. So what is the solution? Implementing parent pointer. Yeah. Oh yeah, they're changing it. They're changing it. They're changing the stuff. Add parent. Current.parent. Yeah, we add a parent. Oh, so you add a parent and then you start from root, right? DFS. Target and K. Oh, you first add parent and then you DFS. I see it. DFS on equivalent graph. So this one, build a graph first. Oh, this is my approach. Build a graph. BFS, build a graph. This is my approach. Build a graph. Answer, visited, yeah. Oh my god. Okay, so this one's done. Not bad. Not bad at all. Alright, what's next? Next is the ones we got a bit stuck yesterday. I didn't really have much time to think, so now let's do some more thinking on this one. So we given us a string. So this is what I was thinking, and yeah, given a string, and we want to find the string that is the smallest string that's larger than this, which is also beautiful, which means it's not palindrome. So I have A, B, C, Z. So what I was thinking, well, I have an alphabet, so I can get the alphabet out. You know, A, B, C, D, doesn't matter, da 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 da, right? And then given whatever is this one, ooh, maybe it'll be easier. Well, yeah, I think it'll be easier to turn this into an integer. So we just like 0, 1, 2, right? And we do this, and then we try to see if we have more. So the first idea is always increment this. If I increment this, as long as there exists something here, I increment, right? It doesn't matter if it's equal to the first one, because we have at least 4, and the starting position is not palindrome, which means none of the center is palindrome. So it doesn't really matter if these two are equal. So you can always get a palindrome, which means if we have more to go on this side, and of course it's not 2, right? If it's not 2, I think we can if it's 2, it has to be considered separately. I would consider, if it's 2, we consider separately. If it's 1, if size is 1, oh, size is 1, it's trivial case, right? We always increment unless there's no way to increment. Size is 2, we increment, right? But they cannot be equal, right? They cannot be equal. So if they're equal, we have to keep incrementing. If not, we have to go back this way. So size is 2 has to be considered. Can we consider that, you know, together with everybody else? That's a good thought, right? That's a good thought. We shall. So depending on whether there is anything in between, right? If there's nothing in between, then we have to consider. As long as there's something in between, then we don't have to consider, because we go from outside in. Anything in between will be handled already. But anyway, so let's just say we move this one up, right? As long as we have something to move up and it's not consecutive, then we already solved it. If we cannot, right, then we need to move to this position, right? We need to move to this position. And if we move to this position, then this position to drop down to the lowest, right? We delete this, drop down to the lowest. And now this whole thing is smaller than that, so we need to increment this, right? We increment this. If it works, then we're good. And of course, these two cannot be the same. If it does not work, right? If this one does not work, let's say I have starting positions A, B, no. What if I start with A, D, C, Z, right? This can now go, so I have to drop this one to A, and this has to go up, and oopsie doozy, can do it, so this one has to go to C. Now, not go to E. Now, what if I can now go? What if K equals 4? Well, K equal to 4, I go to D, I can now go, so I have to move on to this one, right? We have to move on to this position, so it'd be A, D, this one has to drop, right? This one has to drop, it has to drop to some position. Well, it's gonna be like A, B, C, D, like that, right? So it has dropped to A, this will become B, and that's the smallest possible. Oh, it's actually not, because this one actually can be A. Ooh, it's not easy. Yeah, if you think about it, if I have a very long stretch, right? And I'll have A here. This cannot be S, that can be B, but this can be A, this can be B, A, B. I can just A, B, A, B, A, B. As long as this S is not palindrome, right? Man, we can actually try. Yeah, I mean, in this case, it has to be A, B, and D I cannot move up. So I have to go to this one, right? So this has to drop. So I drop this to A. Okay, and this cannot be A, this has to be B. This has to be A, right? And this is A, I have to go up. This has to be B. And what we compare is just, because these will not be palindrome. So this will not be palindrome. This will not be palindrome if we do A, B, A, B, A, B. Right? As you go to the left, the right side will never be palindrome. So as long as you make sure the center is not the same, then we're always going to be good. So be BA, BA. Give it a shot. So I say A, B, D, Z. K equal to 4. That's probably cannot do. Ooh. C. Yeah, we can do C. A, B. No, it's not A, B. It should be A, D. A, D. C. A, D. A, D, C, D. Yes, A, D, C, D. A, D, C, D will become B, A, B, A. Wait, what? Expect beautiful to have value from 1 to 1 only. What does that mean? How is this not a valid? A, B, C, D. Wait. This is not beautiful. Why? Invalid test case. Expected beautiful to have value from 1 to 1 only. What does this test case, what does this even mean? I don't understand. Huh? Any substring of length 2 or more. Oh, this is a palindrome. Oh, I think I got it wrong. I thought the entire thing cannot be palindrome. No, it does not contain any substring. Holy moly. Any substring. So this is not right, because this become a palindrome. So it has to be C. Ooh, dirt. How about A, B, C, D? I don't know. Just trying different things. A, B, C, D. And our choices is A, B, C, D. Okay? So D can now go. So I bring D down to A. Okay? And C, I bring C up to D. Oh, and then already done. A, B, D, A. That is not what you want. And we cannot do D. So what do you think? Well, definitely we try to move up. If I can move up and it's different compared to the previous one, then we're good. Right? Then we're good. If I cannot move up, or if I move up, it's the same as the previous one, oh, then I try to move up again. Right? We just keep moving up unless we can't. If we can't, we'll set this value back down to A, and then we'll check this one. This will do exactly the same thing. We just keep moving up compared to the previous one. And if it cannot, if it works, then we're good, right? If it works, as long as these two are not the same, right? Then we're good. If not, we'll drop this down to A, and then we keep moving this way. Awesome. Now we do have a problem, right? So we drop down this to A, and then we get this one up, right? And we keep going up, keep going up. These two will not be the same. But if this one fails, then we need to drop this one down to A. And this one has to be B. And then we're deciding on this one, right? And if this one fails, we go A. Are we doing A, B, C? Because we cannot drop down to A, because it's a palindrome. So it will be A, B, C, A, B, C, D. So it'll be like that. And what if we have more? A, B, C, A, B, C, A, B, C. Yeah, we don't have to A, B, okay, A, B, C, A. Right? You don't have to A, B, C, D, A, B, C, D. You can do A, B, C, A. That feels wrong, right? It feels not right. So another idea I have yesterday is binary search, but I'm not sure if binary search actually works here. Because if you go a certain string, right, like the kth largest string, then S, and if this doesn't make any, if it's good, do you keep going down? Right? Do you keep going down? Or, I mean, you can always keep going down, but the thing is, if it's bad, which means you can going down still. So that's the issue, right? That's the issue. And yeah, if the last one I keep going, grow, right? We grow up, and if we can now grow, or if it's equal, then we have to drop to move to this side. Then we do, when we drop, move to this side, right? You can keep doing this. You can keep doing this, but the thing is, basically any three, so any value cannot be equal to its neighbor, nor can it be equal to its, like, because these are the seeds of palindrome, so it cannot be equal to this. So this has to be C. There's no other way, right? There's no other way. And yeah, because these two cannot be the same. So this can do A, but then A and A, so it has to be C. But now you go to this one, right? You go to this one, and this is fine. You can go back to A because you are able to, this A has skip, right? This ABCA is good, right? ABCA is good. ABCA is good. ABCA is a valid. Ugh. ABCA is valid. And basically, yeah, we just moved up to D, right? That's how we thought. ABCA is valid. And we can basically just ABCA again, right? Well, okay, so basically as we move to the left, on the right hand side, I can just ABCA, ABCA, ABCA. I can just keep this pattern, right? We can keep this pattern. And K is equal to 4 at least, so we can always do ABCA, ABCA, ABCA. Can we be, you know, slightly smaller than this? Is this the smallest we can go? You cannot. You want to make small, you want to make this to A, that's not possible. Or make this to A, that's not possible. Make this to B, that's not possible. That's smallest is C. Right? This is already A, and this is the same. So, yeah. So we just keep going this side, right? We just keep moving to the left. And every time we move to the left, we just check. Right? We check. We check. And of course, when we check, because we're here, right? We know on the right hand side is going to be this, and what we care about is just this and this. So this value cannot be A, otherwise we'll have a conflict. But hold a second. You say we're going to have a conflict. What if I just move this to A? What are you saying? What are you saying? I am saying that the smallest is always going to be ABCA, ABCA, right? So, but this has to be larger than the original, right? It has to be larger. So we have whatever the original, right? We have the original, and we have to be bigger than the original. So we have to go 1 up. If I go 1 up, it turns into B. Can now go, so it has to go into C. Right? Well, it depends on how many we have accumulated here. So what do you think? Well, what I think is, yeah, for every single position, we compare, we'll bring it up. And as we bring it up, we compare it to this one and the one in front of it. Right? We compare to 2. So we bring it up. If we cannot, we move towards the previous one. And we do exactly the same thing. We compare to this and compare to the one ahead. And we make sure that this does not equal to A or B. Well, I mean, it has to be also dependent on, because this, what if this is A, right? What if this is A and you make this into A? Ugh. Hold on. So I'm at this position, okay? I have some value in front. And if I have everything in the back like this, and I need to be bigger than whatever this one is, okay? Bigger than this. And it cannot equal to this, nor can this equal to this, right? So if these two are equal, we also done. So what if this is A? What you gonna do? If this is A, right, and we're gonna pick whatever, but these two will be the same. So, and we want to have the smallest. We want to have the smallest. What are you gonna do if you want to have the smallest? If this is A and then we want to have the whole thing as smallest, we don't want to increment this, right? And we want to make this just go up. So maybe we just do BCA, BCA like that. We move B to the front. We start with B. What do you think? We start with B. Oh, we start with B. That's not BCA. That's gonna be BAC. BAC. Because we start with B. Right? Otherwise, you move this, it'll become worse. So you stay here. And this will turn to B. And if it's B, we want a small, so BA. And this cannot be A, cannot be, so it'll be BAC, BAC. Right? BAC, BAC. So it's E. So if it's A, then we turn into BAC, BAC. And this will just go up to find whatever value. Right? We go up to find whatever value that's not equal to A, not equal to B. So we try to C, right? Or whatever. And if this fails, then we move on to this one. Right? We try to change this. Then we'll look at this value. If it's not equal to A, then this is going to be ABC, 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 right? And this we just find something. Okay, so what's the current verdict? Well, the current verdict is we start from this, right? And then we have nothing. The length is 0. If length is 0, we only need to consider nothing. So we just try. If it fails, we consider this, right? And then we'll always consider the 1 in front. For this, have to consider these two. And for this, we're going to consider it here, right? We're going to consider here. So we can say like the starting position. What's the starting position? If it's 0, we don't have to consider. If it's 1, then we have to consider, right? And what if this is A, right? We have A, so then this cannot be A. This has to be B, right? This has to be B. Has to be B. So we'll consider this to pick out what this value is, right? And then the two values. Okay, I think I have an idea, but it will be pretty complicated to implement it. Right, so first we need to determine what the remaining is going to be. And then we need to know what the remaining is, right? The length of the remaining. If the length of the remaining is 0, is nothing. If the length of the remaining is 1, we can actually give it whatever this is based on this. Based on this. If the length of remaining is 2, we can have both. If the length remaining is 3 or more, we don't have to worry. We don't. We just need the 2. Is it AB or BA? Right? That doesn't really matter. AB or BA, AB or BA. And we just, compare. So let's give this a shot. Okay, so what are we saying? So we have alphabet, right? Alphabet. Really? Do you want to do alphabet, or I think you said you want it to be just values, right? We can just do values because I want to know what's the next one, right? What's the next one? So I have k is a limit, right? K is a limit, which tells you if the OR is larger than this, then it doesn't work. So we don't need an alphabet, right? Okay, let's say for I in range, -1, -1, -1. Okay, then we can say on the right hand side, right? On the right hand side, the size on the right hand side is okay, let's do this. If line s is equal to 1, if s is 0, ORed s is 0 minus 97, yeah, if this minus 97 is smaller than k minus 1, right? If it's smaller than k minus 1, so like 0 to 25, so if it's smaller than k minus 1, then we can plus 1, right? We can plus 1 and we're smaller than k, and it will still work. Then we can say return char ORed s0 minus 97 plus 1, else return empty. So that's that. Otherwise we do this, right? Otherwise we do this. And then we need to see the remaining, the right, len right RRL is equal to len s minus I minus 1. Right? This is the number on the right hand side. So this is the lens. And then I have the current, and I have the one in front. Oh, I have the one in front. And I have the 1, 2 in front. So what I need to do is well, first we need to check to make sure what the right hand side is going to be, right? So if I minus 1 is large equal to 0, then I say if ORed s I minus 1 minus 97 is equal to 0. Start, right start, right? Right start. Well, also depends on if we have, okay, so if RL is equal to 0, we're gonna do whatever. Else, okay, let's do this first, right? If RL is equal to 0, the right length is 0, then I shall start from myself, right? Start current one, and we say We need to first settle down. Okay, let's first settle down. Yeah, we need to first settle down. So, if we have the left and RL is larger than 0, right? This is to settle down. And we can say right start is gonna be 0. Right length and right start. Okay, and if this is equal to 0, then right start equal to 1, right? Otherwise it's fine. We can always start from, so maybe I can do this, and then we set RS equal to 1. That is to prevent as a something, right? So I have the right start, I have the right length. Now I can go from myself, right, the I. So what I need to do is do the current one plus 1, right? We say for, no. So we say current is equal to ord SI minus 97. We say while current is smaller than K. Okay. Current plus, now current will be this plus 1. While this is smaller than K, then we use the current to compare to the left and compare to the right, right? When you compare to both. So, like, what is it that it works? We say if so the checks. Okay, I have a bunch of checks. We check on the left hand side first. I minus 1 large equal to 0. And should be like I minus 1 smaller than 0, or ord SI minus 1 minus 97, right? So if it is smaller than 0, if it's true, then we're already true. We don't have to, because it's short circuit. So if this OR is larger than 0, then we check it's ORed, and this need to be not equal to current. First check. Second check, I minus 2 smaller than 0, or ORed SI minus 2 minus 97 is not equal to current. Third check on the right hand side, R lan is larger than, R lan is smaller than 1. Okay, or ORed, we have RS. So RS is not equal to current. R lan is smaller than 2. Right, if it's smaller than 1, which means this is 0, right? This is 0. If it's 0, then I don't have the concern, right? So maybe I should just say no. It should be this is equal to 0, or R lan is equal to 1, and this is not equal to this, or Rn is larger or equal to 2, and Rs is not equal to current, and the next one, right? Something. So I can say current is not equal to 1 if Rs is equal to 0. Else current is not equal to 0. Yeah, if Rs is 0, and then go to more right, it's gonna be a B, right? It can be a B. Now if it's a B, it's a 1, so this cannot be 1. Else, if this is 1, then let me do this. Current is not equal to 0. If it's a B, then we cannot be a. So these are the checks, right? And hold on, I'll be back soon.
That's fine. Which one?
Sorry. That's okay. Don't worry about it. You're so sweet. Alright, let's see. I have this one right. So we check. In fact, I think this is not right. I think it should be the same. Okay. So should be I minus 1 smaller than 0. Wait, hold on. If I minus 1 is equal to 0, yeah, I minus 1 smaller than 0, or I minus 1 is equal to 0, and this, or I minus 1 is larger than 0. Yeah. I minus 1 equals I minus 1 is larger than 0. So I minus 2 is equal to 0. So now we have to do both. Right? This is not equal to. And this is not equal to. Both. Right? If this is equal to 0, so I minus 1, so we just check that. if I minus 1 is larger than 0, like, no, 1, I minus 2 becomes 0. So we have two things to check. This has to be not equal to, and this has to be not equal to. So these are the checks, right? Now we say if all checks are both pass, then we'll have the current, right? We'll just break, right? We'll break. Then whatever the current is, that's good. If not, current plus equal 1. So we keep doing this, then we come out. If it's else, which means we never have a break, then this is bad. Then we just continue. Right, we move on to the next one. We move on to the next one. We redo this. Yeah. We redo this, we check again, Otherwise, if we break out, then we can break. I think we already found the solution, right? So we break out. Now I think we can return here. We can return here. So we have I. We have the current, what we need at i's position, we know is current, and the remaining we also know. So what's the solution? S all the way to I, right? Not all the way to I, not including I, and i's position should be char current, and the remaining is going to be R start, right? R start. R lan, we have R lan, and we shall do, what do we do? We're going to say result equal to this. And then, if R lan is equal to 0, return result. If R lan is equal to 1, return result plus character rs. If R lan is equal to 2, then no, I think I can build this. So rs, so the R pattern shall equal to char rs plus char R pattern equal to ABC if rs is equal to 0, else BAC. Okay, so if it's equal to 1, doesn't really matter. We can do quotient remainder R lan div mod R lan and 3, and we'll return res plus q times R pattern plus R pattern all the way to R. Wait, hold on, does this work? A times 0. Yeah, I think it works. So we'll return this. Oh, then perfect. We don't have to check. We just do this. We got a pattern. If it's 0, it'll be 0 and 0, so it'll be 0 and 0. So we'll return this. If nothing works, we'll return this. Okay. Alright. We already passed the time, so we're just going to run this. ABCZ 26 ABDA. If it doesn't work, then we'll go back to it tomorrow. ABCA. I am hungry. I want to eat. ABCD. S. Okay. S. Okay. E. Where? Sorry. Or minus 97. Jeez, man. Ugh. Whatever it is, doesn't look right. And got some weird stuff coming up. A, B. What is that? Oh, dude. This has to be plus 97. All right, let's give this a shot. Very low likelihood it will pass. What? No, man. Okay, this is a this is I got this wrong. Return char this. Oh no, you don't minus 97. You just plus 1. Man. Yeah, it's dumb. This is a dumb mistake. Alright, now we have a real thing to deal with. I think we say this is good, so I never keep going. Output DCAB. Oh, I see. I got AB. This one go to, because A doesn't work, B doesn't work, I go to C. And I say this is good. But here we can do swap. That could be AC. I think this is the right way, but we just need to be it's not just ABC, right? It's not. Because we have to consider starting from this position, right? Whatever this position is. If this position is a B, or this position is a C. No, if this position is a B, this position is an A. It cannot be an A, right? So this position is going to be a B. If this position is a B, then this, it can be an A. But this cannot be a B. So this has to be a C. But if this goes higher, then you do AB. Okay, so let's fix this tomorrow. I think it's for this one alone, it's not a difficult fix. So we'll DBAC. We'll do this again, but not today. All right, so call it today. I'll do this tomorrow. See you guys tomorrow. Adios.